It's the end of a long and rich day at Aquatec in Amsterdam. But if you were not here, what exactly did you miss? Let's find out. What's new and noteworthy? That's the question on everyone's lips in such a trade show. The enthusiasts will tell you that every single company was here with incredible new things, and it's not true, while the jaded people will simply grumpily conclude there wasn't anything interesting around, and that's not true either. I'm not pretending I'm the sole holder of truth, but I've done my due diligence walking the floor. Here are my top 5 of the coolest, noteworthy stuff to take back from Amsterdam, whether you were around or not, starting with number 5, the cool kids are growing. Don't get me wrong, I'm not using this one to shamelessly promote my podcast. I just want to highlight how many of my former guests had booths everywhere around the floor, like Aquacycl, that just announced its first European offices, Membrion. Greg was overwhelmed with super interested visitors, so I had to annoy him over his lunch break. Membrion, still rocking the show in a similar fashion they did 2 years ago. BluElephant Technologies, celebrating commercial milestones in Greece. Aquacycl, beefing up their team in a significant fashion. Or Drupal, showcasing some spectacular savings enabled for their customers. And many, many more I just genuinely met walking down one alley or another, or over a coffee. As an overall trend, you had technology companies showcasing their progress on their booth and often on specific pavilions, and investors rather walking the floor and having a ton of dedicated conversations both formally and informally. I had great chats with Kobe Nagar, Wayne Barn, Paul O'Callaghan, Björn Otto, Nicolale Ravelo or Walid Khoury, and almost equally great discussions with a bunch of people that have not been on the podcast yet. Some might very soon, but no spoilers today. So my summary of that number 5 would be, if you're like me and don't like trade shows so much, this one is special. It's only water people, so that even the most serendipitous encounters will be of high value. More to that later. And it's great to see my cherry-picked podcast guest doing so great, which offers me the smoothest of all transitions to number 4. Zwitterco has done it again. If you've never heard of the superpowers of Zwitter ions, you've probably missed my deep dive with Alex Rappaport. When we met again at the Global Water Summit in Berlin, Alex and his co-founder Chris Drover hinted at the next steps they envision beyond their superfiltration membrane banger. Well, the future is here, but I'll let Peter Ingara, their VP of Sales, explain.
Zwitterco has taken our Zwitterionic copolymer chemistry, we've applied it to a standard industrial-grade polyamide RO membrane, and we've unlocked the potential to solve all RO cleaning issues, organic fouling, biofouling. The Zwitterionic chemistry that we've demonstrated and proved in the superfiltration, applying it to an RO membrane, we've seen the unprecedented performance of very long time between cleanings, and a very simple 10-minute water flush fully restores the membrane to desired initial flux. There's a lot of systems that are struggling to maintain their desired performance and output. We leaned into it and we have a new developmental RO product. So we've lined up a series, 2 Wastewater we'll be launching with, a high rejection, operates at standard pressure, and a low energy product meant to be a full drop-in replacement to existing RO membranes that are in the market today.
Let me repeat Zwitterco's promise here so that we all get the magnitude of what we're discussing here. The idea is to leverage the Zwitter ionic material's ability to prevent organic matter from binding strongly with it in order to wash it off with only water and no chemicals, while basically experiencing an almost complete absence of fouling of any kind over extended working cycles. I've managed to watch some graphs over Peter's shoulder. I guess I'm not breaching any secret, they didn't hide it from me, and the curves look impressive. Basically, there is no curve. The membrane simply maintains its performance almost regardless of the organic load it's receiving, and if it starts behaving like a normal membrane and slightly drops off because of the crazy loads it's been tested with, 10 minutes backwash and you're back to normal. Of course, that's Zwitterco's data and it will need to be double-checked in the field, right?
We're actually doing a lot of pay-for-performance models on this right now and say, install this, we'll show you the performance that you won't clean. You've been cleaning monthly, give us 6 months. I don't think you'll clean in 6 months. You've seen the value, we see the value, everybody wins. So what happens when you clean an RO membrane today? You get more salt passage over time, which then leads to the membrane replacement. We don't obviously have enough data to say that the membrane is going to last X number of years, but if you're not cleaning the membrane aggressively and you're only cleaning it with water flushes, theoretically, the membrane should last significantly longer as well. The early access program that we're launching is open for people that want to see firsthand. Coming soon, that's right. We go through and build out an economic model. So it's sharing of data. How often are you cleaning? How often are you replacing membranes? We want to make sure that this opportunity makes sense for both companies. Once we do that, we do a water quality analysis, typical RO stuff. We have the value case, then we get an install, get an order, we install it, we monitor the data, we deem success, we define KPIs. Here's the 2 to 4 KPIs that this site needs to have this make financial sense. And once we get through that, then we say 6 months, everybody's happy.
Honestly, I know it sounds almost too good to be true. And I know I mentioned several times that silver bullets don't exist in water treatment, but take this. It's not a silver bullet. As of today, it's not seawater desalination, it's brackish water desalination. I have no doubt it will eventually grow into seawater, but for now, it's not. Then, still according to the graphs I saw, at first, it didn't fully meet the flux rates of today's technology. Zwitterco has been working on it, and today's product you can get with the early access does 1-to-1 meet the incumbent membranes. But again, it wasn't a given and it got worked on and developed. I'm just mentioning that to calm all our snake oil detectors. Honestly, that technology sounds very legit, and the promise to test it for yourself is pretty appealing, given the potential it's unveiling in an array of applications from desal to reuse. It's worth mentioning I don't have any stakes in that game. I'm just genuinely impressed by the pace at which Zwitterco is developing, which makes me wonder, what's next?
We have 2 brackish water products today. We're pursuing drinking water certification, haven't received that yet. We're also evaluating seawater as part of our expansion. Zwitterco, this is a platform technology. We came to the market with 1 product, superfiltration, doing some really interesting things in wastewater reuse. But it doesn't sound like a platform with 1 product. Now we're demonstrating the platform. Here's 2 products, here's 3 products, and then we're proving that we can make products within the full membrane filtration spectrum.
So again, what's next?
Probably is seawater, NF. People, come talk to us. What do you want to see next?
If you have an opinion, reach out to Peter and the Zwitterco team or write to me. I'll happily pass the message over. For now, it's time to move to my number 3, which is innovative in a fully different direction. Let's get to meet the BluElephant. What's that?
A BluElephant is a solution that works, we say, and in this case for the wastewater treatment plants. It's special because it's a small scale MBR, so it's for 100 to 150 people a day it can treat the water. It's fully biological with an ultrafiltration membrane in it. So it's a complete MBR system and also has a second treatment step for UV disinfection. It gives you a double barrier approach. It's a 1 solution, but it gives you safe water to use for irrigation or other purposes.
Okay, so it's an MBR tailored for reuse. That's pretty cool, but why would it be cool enough to be in my top 5 from Aquatec? Well, first, maybe because of its look.
The looks are partially because it's a nice form to see, but it also is functional because the internal parts are all centralized around this globe shape. And this globe shape is also the tanker where the solution of sludge is in. And it will give you, for the circulation, an optimal form to have no dead areas.
So the look is cool, but this is still not water fashion channel, so it wouldn't be enough to qualify. Actually, the special kick of this MBR/UV solution lies in its operation. Take it with a pinch of salt because it's not Hot and Water Solutions or BluElephant's words, it's mine. But that thing, on top of being designed to be working off-grid, is stupidly easy to operate, which makes it pretty autonomous, right?
It is autonomous, but it needs an operator, so someone who understands the system to operate. It's about 1 time a week, and then you can check the system, maintain it, and I think you need a few hours to keep the system alive and running.
When I'm saying stupidly easy to operate, it's because probably even someone like me would be able to run it. You don't need to be super skilled beforehand.
Not highly skilled, but you need some training for it. We can train the people to operate it in 1 day. It's relatively simple, and it doesn't need a lot of knowledge of the technique and internal parts. So you can use it, operate it, and maintain it very simply.
So, tailored for water reuse, autonomous, easy to operate, designed for off-grid applications, and by the looks of it, affordable. Where will these BluElephants be deployed?
It is in fact one system, it's one unit, but it's modular, so you can place more elephants next to each other to get a greater scale. Villages, small communities that can use it as one system to treat their water. You can aim for small communities over there, small villages that can use it and that have no water treatment systems. It's decentralized and you can use the water of that system directly for irrigation purposes.
And if I'm using the future, it's because BluElephant is a joint venture of Rotem Water Solutions and Rob van Opdorp Designs, and is actually in rolling out phase.
We have several working prototypes. We have it live operational in several parts of the world. In the Netherlands, we have a system running that we keep very close contact with operational people, so we can look at the results and measure the quality of the water that it's producing. We also have 3 units in Palestina that's treating water of the hospitals and then make a safer irrigational water of it. The next 5 years will be used for further outroll of the full concept. But now it's a functional prototype, but we are very busy with making it ready for the serial production. In 5 years we will have the first serial production units operational overall around the world.
Again, to put a bit of emphasis on the ideal product market fit, remember that 3.6 billion people in the world still lack access to sanitation. What it looks like, that's a bold opportunity for a win-win-win-win-win.
What we can do for those environments, it's giving the people a real solution for the water they can't use right now, but then we can make it for them usable and also safe. So it will bring higher standards to hygienic in the environment and also safer water.
In a nutshell, I believe BluElephant gives us a great example of translational innovation here. Something we maybe undervalue in the water sector. As the name suggests, translational innovation moves a technology or solution from its original context to a new one, thereby transforming its application and often its user base. MBRs are usually large or at least on-grid. Here's an off-grid small-scale take that leverages 3 techniques you can apply yourself starting today. First, technology transposition. Often not just a simple application, but also a creative adaptation to fit the new setting. Second, scalability and adaptation. Going back to the technology's fundamentals to double down on its core functionality. And third, simplification. In that new context, you can't afford complexities, so you have to increase accessibility and operability while reducing costs. All in all, not a flashy innovation, but in my book, a super interesting one. Which leads me to number 2, all the small serendipitous unflashy stories I collected from Aquatec, aka somewhat of my editorial take. Actually, in that number 2, I could have focused on a specific story I collected on Loist's booth. If you don't know Loist, it's a mineral and lime producer and the world leader at that. A lime, let's be honest, is a pretty boring topic. And I know one thing or two about being boring working for a piping system company. What I mean by that is that it's a topic that is almost never top of mind. Yet, lime has quite a carbon impact and hence could benefit from switching to greener production means, which by vertical integration would have a significant impact on many industrial players' Scope 3 emissions. Loist is in the process of doing just that, and it's a huge endeavor as they're switching from grey to blue lime, lime with carbon compensation, and are in the process of moving to green lime, lime with carbon capture. They're also working on circular lime, by the way. I'm not going deeper into the details because I want to make a specific deep dive into it. I actually see it as my duty to shine a bright light on the incredible work that's done on otherwise pretty boring topics. But what I want to point out here is that I had 1, no clue about lime's carbon impact, 2, barely an idea on who Loist even is, and 3, not planned by any stretch of the imagination to stop on their booth and have that 45 minutes fascinating conversation. So what that shows is that as a company exhibiting on a trade show like Aquatec, you know that the visitors will have a very defined persona. So it's your chance to be super specific and to boldly push your agenda or topic that would be boring to 99% of the population, but not to the 1% attending Aquatec. To that extent, Aquatec is unique. A much larger IFAT or Akema will have water people walking around, but diluted in a mass of other personas. And so your hit rate with a potentially boring story is going to be much lower. Another way to benefit from that very specific visitor profile is to do what Naihu Store Industries did on the front of their quite large booth: advertise your job openings. Our industry struggles walls to fill all its positions, yet the exact people who may want to join you are walking the floor. Leverage that, and bonus if, as Nijhuis did, it's your CEO that's standing next to the job screen.
Oh, that's clever.
When I was wondering if it was worth it for me to leave home once again this year and attend Aquatech, people told me I shall because it's unique. Well, thanks for convincing me, because indeed, it is. Where else do you see a CEO with a 33,000 following on LinkedIn DJing at an evening party on another company's booth while sipping an Amsterdam Canal water beer? Where else do you see the CEO of a $1.3 billion yearly revenue water company, Reinhard Hübner, explain in a f***up night how the first M&A move of Ski on Water was a disaster that cost millions? Well, he did on my podcast as well, but he went into even more detail at Aquatech. I've been bumping into great people at every corner and adding so many topics to my bucket list that it confirmed me I need to hire an editor for this channel, because yes, I have a day job, a family, and I still need to sleep at night. Something funny as well was to see a shift in marketing beyond the super targeted examples I mentioned with Loist and Nijhuis. When I was working on Aquatech booth for De Gremont over 10 years ago, we had a wealth of goodies to give out. Take your pen, your tote bag, your Rubik's Cube, your USB stick, your glass and straw, your brochure, and so much more. Those times are gone, and it's a great thing. I'm coming home without a single physical good, besides some business cards. On a marketing level as well, there's an interesting cultural difference between Chinese companies and others. At a Chinese company's booth, you'll find a wealth of stuff to read. Posters, studies results, numbers, facts, and a few figures. Much less so on other booths. The extreme probably being the Zwitterco examples I mentioned earlier, where you had one membrane, one QR code, 3 smiling people, and a laser-focused message. Our new product is incredible, test it out. One last marketing word before I wrap this number 2. There were very few cameras on the floor besides mine. I've seen a couple of teams with a similar setup to mine, a big camera and a 360 smaller one, but that's it. To that extent, Aquatech stays true to its motto: you have to be in Amsterdam to be in Amsterdam. No live stream, no replays, but a bunch of interesting takes that get you thinking, like my number 1 for today, the company that wants to give your toilet paper one more life.
We reuse toilet paper. 20 to 30% of your load to a wastewater facility is toilet paper. Every Dutchman uses about 1 roll of toilet paper per week, which accounts to 15 million rolls of toilet paper that are being discharged to the sewage every week in the Netherlands. That's a lot of toilet paper. Currently, you use a lot of energy to take them out of the water, and you produce a lot of sludge, which we burn, which is 80% water, so it doesn't burn that well. So that's very bad for the environment. Our solution is just take it out up front, and then you can choose what to do with it. We promote digestion, just make biogas out of it, or you can reuse the fiber and make construction materials of it. Anything that's made of cellulose can be made by this cellulose as well. So I prefer the wet route, digestion, green gas, and put the green gas in a car. It can be stored. That's much easier and much better for the environment.
Okay, but you may wonder, if your wastewater treatment plant already has a sludge digestion step, what would it change to take out the cellulose to digest it?
In a sewage treatment plant, 70-80% of the cellulose is being digested already in the biology. So all the energy component is being taken out by the aeration and turned into surplus sludge. And that energy component, the cellulose, we take out up front and digest it, and then it turns into a valuable energy source. You get 10-15% extra capacity in your biology. Your loading goes down by 15-20% as well, your organic loading, which means less nitrogen oxide, lower sludge loading, which means very good for your nitrogen removal, and you get more active biological per kilogram of sludge because you take out all the organic inert.
So that's the principle, but how does it work in concrete terms?
This technology is not new. A guy that's standing on another booth developed it together with WaterNet, one of the water boards in the Netherlands, and I thought it's not the most optimal way. I think I could do better. We tested this technology in our back garden and we saw that it worked, and then it developed. If you have a sieve, then your aim is to take particles out of water. And if the particles are solid and round, then it's not so difficult to retain them with a sieve. Just make sure that the holes are a little bit smaller than the particles and everything is okay. The problem starts when you have fibers, much larger particles, but if you want to separate the fibers with a sieve, then this is what happens. You will retain a couple of them, but most of them pass through the sieve. So what we did, we tilted the sieve from this one to this one. So only 15 degrees with the path of the fiber. And then this is what happens. All the particles are on that side. It will not be able to pass. In water treatment, the flow is not from the top to the bottom, but it's from the left to the right in a channel. And if you do it like this, then it's easy for the fiber to pass. So what we did, we tilted our screen to 15 degrees with the floor. And now, if the fiber goes from left to right, it will not be able to pass.
Interesting, right? But to figure it out at the real scale, what would be the size of the holes in the sieve?
They all use 300 micron to separate the fibers out of the water. We use 1.5 millimeter. So the dimension is 5 times bigger all. That's the diameter. So actually the surface area is 25 times bigger. So it's much easier to clean. Water can pass easier. Cleaning is easier, which makes the system very affordable, about 1/3 of the cost of the competition. And the operational costs are a joke.
And joke or not, that sieve traps 50 to 70% of the cellulose that enters a wastewater treatment plant. But does it also trap unwanted stuff?
That's depending what you say, unwanted stuff. Unwanted is defined by what you do with the pulp at the back end. If you put it in a digester, then hairs don't mind too much. You just put it in a shredder and everything goes into the digester, even if you have a piece of plastic, through the shredder, and it digests very well. So for the digestion route, which we prefer, it's not a problem. If you go to the cellulose upcycle technology, then you want to have cleaner cellulose. Typically, we would use the same system, but then 2 in a row. The one we will put quite upwards with big holes, and one flat with smaller holes. This one will not remove any fibers because they will pass. This one will remove all the fibers. This one will remove all the hairs and all the big stuff. This one, you get a clean cellulose out.
In case you'd be interested for your own plant, what's the technology's development stage?
We have a prototype 6.5 meters by 2.5, and it's 10 square meter of surface area, and it's able to treat 700 to 1,000 cubes an hour of sewage. This week, maybe next week, we will get the first intention declaration for the construction of a first full-scale unit, and then we go from TRL 7 to TRL 8, which is demonstration. So we're almost to TRL 9, which is just buy it and it's business as usual and making a lot of money.
For it to make a lot of money, you need to remember the name of the company, which is a funny story by itself. They're called Purgatoria. But why Purgatoria?
That sounds cool. Charta Purgatoria is Latin for toilet paper. The charta is the paper, the purgatoria is the stuff you want to get rid of. And we want to focus on the want to get rid of stuff. Paper is recycled about 25 times already in the Netherlands. And we want to give it one more cycle. One more cycle, that's the purgatoria part of it. The stuff you want to get rid of, but not yet.
And voila, I think you get why that simple, sturdy, clever piece of technology got me to rank it my #1 pick to bring back from Amsterdam. And I think by now you also feel I had a great time in the Netherlands talking water with water people. Did you also attend Aquatech? Did you have different picks than mine? Do you have a different opinion than me on my picks? Come tell me in the comments, send me a message on LinkedIn, and I'll be thrilled to discuss it with you. Remember, if you're fond of water technology, its application, its financing, its innovation, its impact on the world, well, I discuss all of the above on this channel every week, sometimes alone, sometimes with incredible guests. If you don't want to miss out, hit the subscribe button. And if you're already subscribed, thanks a lot. If you think this one would be of interest for one of your friends, colleagues, your boss, or your team, share it with them, and I'll see you next time.
But